In this video, we're going to look at graphing a quadratic equation using a table. There are lots of ways to graph quadratic equations, and one of those ways is to just substitute in values for x and see what you get for y. That will give you ordered pairs that you can plot on a graph like this. So I have my equation written out right here. The equation is y is equal to negative 16x squared plus 20x plus 100. And this equation models the height of a diver above water a certain number of seconds after the diver jumps. So again, x is the number of seconds after the diver jumps, and y is the diver's height above the water. I have my axes labeled here. This is my x-axis. This is my y-axis. And I have just this spot carved out of the graph to give myself room for something that I'm going to do later. Okay, so the first thing that I want to do is I want to make a table. And so I'm going to draw a purple line over here. And I am going to write in some different values for x, and then we can evaluate for those values to see what we get for y. So in this column, I'm going to have my x variables, or my x values, and then in this column, I'm going to have my y values. The number of seconds that I'm interested in are 0, so when the diver first jumps, and then also the diver's height after 1 second, 2 seconds, 3 seconds, 4 seconds, and I think that will be enough to see when the diver hits the water, but I'm just going to add a ... here, just in case we have to add more values for x. Now for y, I don't know exactly what y is equal to when x is equal to 0. I have to use this expression in order to figure that out, so I'm going to copy down this expression, so negative 16, and then I'm going to put in parentheses wherever I have an x variable, and then plus 20 times whatever I'll have for x, and then plus 100. And then once I evaluate that, I'll see what it's actually equal to. Next, I'm going to copy and paste this expression because I'm going to be reusing it. So copy, paste, and I can just move this down because I'll be using it for each line here, and then paste again, and down, paste again, when x is equal to 3, and then one more for when x is equal to 4. Save myself a little bit of writing there. And now inside the parentheses, I'm just going to put whatever my value is for x. So first, my x value is 0, and then my x value will be 1, and then 2, and then 3, and then 4, and then 5, 3, and then 4. Now I just want to evaluate what this expression is equal to. So negative 16 times 0 squared. 0 squared is just 0, so negative 16 times 0 is 0. 20 times 0 is also 0, so the only term I have here that's not 0 is 100, so that's what I'm left with. So when x is 0, y is 100. That's my first ordered pair, and I'll plot that here. X is 0, y is 100. It's that point right there. This is where the diver starts. So at 0 seconds, so it's right as the diver jumps, and the diver is 100 feet above the water. It's a tall dive. Okay. Next, negative 16 times 1 squared is the same as negative 16 times 1. So I have negative 16 and positive 20 because I have 20 times 1 here. So that's equal to 4, and then I have 100. Plus 100, so this is 104. So when x is 1, y is 104. So I have 1 here, and each of these minor tick marks is 5, so it's going to be right below that one right there. And then next I have, negative 16 times 2 squared. 2 squared is 4, and negative 16 times 4, 16 times 4 is 64, so that'd be negative 64. And then I have 20 times 2 is 40, so negative 64 plus 40 is going to be negative 24. And then negative 24 plus 100 is going to be positive 76. So I'll write that, positive 76. And then here I have negative 16 times 3 squared. I'm going to have to actually use some scratch paper here to figure this out. So negative 16 times 3 squared is 9. So negative 16 times 9 plus 20 times 3 is 60. plus 100. So 9 times 10 is 90. 9 times 6 is 54. So that is, let's see, 90 plus 54 is 144. And then we have the negative sign here. So it's negative 144 plus 60 plus 100. And then negative 144 plus 160. And then finally that works out to negative 144 plus 160 is 16. 16. And so I'll put that right here. So when x is 3, y is equal to 16. Right here. So at x is 3, y is 16, which is going to be just above that tick mark right there. And you see our graph is starting to take shape here. And then I also want to evaluate at x is equal to 4. And I know I'm going to need some scratch paper for this one too, so I'll do that down here. Negative 16 times 4 squared. 4 squared is 16, so that is negative 16 times 16 plus 20 times 4 is 80 plus 100. I don't know negative 16 times 16 off the top of my head, so I'm going to use the area model. And remember, with the area model, we make ourselves a rectangle here, and we're going to fill it in with the values of multiplication once we break it out. So negative 16 broken out into tens and ones is negative 10 and negative 6, because negative 10 plus negative 6 makes negative 16. And then 16 broken out into tens and ones is 10 and 6. So what's negative 10 times 100, or sorry, negative 10 times 10 is negative 100. Negative 6 times 10 is negative 60. Negative 10 times 6 is negative 60. And negative 6 times 6 is negative 36. So I can add all of these together. That's negative 100 plus negative 60 plus negative 60 plus negative 36. And that's negative 100 plus negative 60, that's negative 160, plus another negative 60 is negative 220. And then we have another negative 36, which works out to negative 256. So negative 256. You could also use a calculator there if you want to. So I have negative 256 plus 180. 80 and 100 makes 180. And then negative 256 plus 180, that is negative 76. Negative 76. So kind of involved, pretty involved simplification there, but we worked it out. So now we have negative 76. See if I can write it small enough there. Negative 76 when x is equal to 4. And now I don't have negative 76 on this graph, but I'm just going to put an arrow down here to show that that's where that next point will be. So we have our graph here through these 3 points. I'm just going to sketch about what that graph would look like. Something like this. And then down through this point here. About like that. That's not bad. Down through there. And so we have a general idea what this graph looks like based on these 3 points. We know the y-intercept exactly, and we know this point exactly, and we know this point exactly. One thing we don't know exactly is where the parabola crosses the x-axis. It's somewhere around here. We don't know the exact number. This gives us a pretty good idea of the height that the diver is above the water after a certain number of seconds. Now it's easy to look at this and think, oh, this is like the path in space that the diver takes toward the water, but it's actually just the relationship between the height and time from when the diver jumps. So again, this is graphing a quadratic by making a table. We just chose x values and then substituted those x values in, and that gave us y values. We graphed those points and then sketched a parabola based on them. Not as exact as actually evaluating for the intercepts and the vertex, etc., but it gives you a pretty good idea of what the graph should look like.